Hello everybody. So what we are going to do today is what we call the resonance lab. Unfortunately, we are all at home right now, so we don't get to do this lab in the actual classroom. So be jealous of my kids. So just like with our standing waves, I have my lovely assistants. We've got Miss Rosalind, we've got Mr. Dominic, and we've got Mr. Benji applying bubbles. All right, so here is our data table. We're going to do 4 different frequencies. As you can see, 256, 320, 384, and 512. And we're going to measure the length of the tube. Now, what tube are we talking about? That would be this guy. This is a PVC pipe that is in water. And what we're going to do is hit these 4 tuning forks against that green block, and it is going to create that resonant fundamental frequency that was talked about in the videos. And you'll notice that on the tuning forks are those 4 numbers in our data table. 256, right there, 312, 320, 384, and C prime. C prime is, well, this is middle C. Middle C is 256 hertz. This is E, this is G, and then the C above middle C is 512 hertz. All right, so what we're gonna do first is show you how to hit these. So we're gonna take a tuning fork. We're gonna hit it. Wait, I'm gonna do this as close as I can. Hopefully we can hear it. Stop moving it. All right, hit it again. I don't know if you can hear that or not. We'll find out. All right, so what we're going to do is we are going to hit the tuning fork against the green. Ready, Dom? Mm-hmm. All right, here we go. Yep. So hit the tuning fork, and he's going to lift until he hears a sound. All right, so we're going to do that again, and what we're going to do is go below it and above that point. And what we should notice is it's only, please don't do that, Dominic.
There's a bug.
I know, we do not use these to kill bugs. We should notice that there's only a specific length that it will resonate. Resonating means increasing amplitude, which means a louder sound. Ready? Let's do it. Now go above, keep going up, disappears, and it's back. So there is a specific length. Miss Rosalind is going to measure said length from the water level.
34 centimeters.
All right, so let's add that to our data table.
Centimeters is more superior.
Yes, it is. We always use metric, don't we?
Yup.
And we do it from the water level because what is happening is the tuning fork is causing the air that is inside of this PVC pipe to move. And only the air that is inside of the pipe will move. Once it hits that water level, then it stops moving. So anything above the water level is what will make the sound. All right, you ready? Let's do the next one.
320 hertz.
320. All right. Let's do that one more time.
My turn.
All right, you ready to measure, Rosie? Perfect. Yeah, we'll let you do one soon, okay?
But not during the video. About 28 centimeters.
All right, let's put that in there. And hopefully you were able to notice that the pitch that we heard from that other tuning fork, was it louder? Or sorry, not louder. Was it higher or lower pitch? What do you two think? Was that a higher pitch?
Bit higher.
Bit higher. So higher frequency means a higher pitch.
Ouch.
All right, ready? Here we go. Third one.
I bought it. I pickled. My butt shake wiggled.
All right, let's go down. I think it's lower. There it is. Look at that nice loud sound. Loud means high amplitude, which means it is resonating. All right, let's go.
About 22.
22. All right.
That's 4 less. This is 6. This is 6 less than that.
Oh, you're
This is 6
right.
more. And that's 4 more. That's 4 less than that.
Is it?
14 more. They're 14 less. 14 less and then 6 less. So this
Do that math again. What's 34 minus 28?
it's 8. No, it's 6.
It's 6.
And then this is 6 too.
Interesting.
So it goes down by 6. So I think it might be. Next time it might be. Oh, it's 16. I think it might be 16 next time.
Interesting. Well, we'll find out. All right, ready? Here we go. 512. Oh, too high. Go down.
I couldn't find.
Keep going down.
Elsa.
There it is.
Awesome. 18.
18? That was close. That was an interesting observation, kids. What we are really looking for, though, is as that frequency, we can definitely see a trend. Now, that was a really high pitch, wasn't it?
Yeah.
Yeah, that was a very high pitch. So as frequency is increasing, our pitch is increasing. And so now if we look at our data, as our frequency increases, what happened to our length?
It went down.
Yes, it did. It decreased. And so if the length of the tube decreases, the reason why is just like you saw in the simulation, it's because of the standing wave. A shorter length of the tube means it has a shorter wavelength. So higher frequency, smaller wavelength, inverse relationship. And we saw that in the lab. All right, thank you, kids. Now, what's also very interesting, let's just go back and look at these tuning forks one more time before Ben grabs one. All right, well, we'll use those 3. So what you should notice is we have a smaller frequency here, 320, right? And we increase in frequency. What do you notice about the length of the forks?
As the frequency is higher, the length of the tuning fork is shorter.
Yes, it is. So higher pitched instruments are usually smaller instruments, and lower pitched instruments are usually larger instruments. All right, hopefully that was fun and you were entertained by everything going on in the background as well. I'm sorry we didn't get to do this lab in person together in the classroom, but at least you got to see it. Thank you guys. Miss you tons.